that we need to do is draw the free body diagram. And I'm just going to draw over the picture that we have here. So let's go through it point by point. So at point A, we can see that there's a pin and it can rotate, but it cannot move in the X or the Y direction. So because it can rotate, it's not going to have that moment reaction force, but because it can't move, it will have reaction force in the X and the Y direction. So we're going to draw like this, just say A of Y and A of X. At point B, there's no pin, but there is a force of P being applied. The same thing applies at point C. At point D, there's nothing happening there. And at point E, we have a roller that is touching the ground at an inclined angle. So this one, it can move in this direction, which means there will be no reaction force, but it can't go through the ground. So we're just going to apply a normal force, E, or force of E. And that's the whole free body diagram. Now if we want to break up E into its separate components by similar triangles, if we draw a line going down this way, this angle right here is equal to that alpha angle right there. So then you can find its separate components by doing cosine and sine. All right, so that's the free body diagram. Now we need to determine the reactions at A and E when alpha equals 30 degrees. So what we can do, going into a problem like this, we can see that we're given P, so we have two knowns right here and here. And we don't know the force of E, and we don't know the force at A. But we do have this angle, and we know nothing about these A forces. So what we can do is we're going to take the moment about A to eliminate them from the equation and basically hide them. And that's going to allow us to solve for E. So I'm going to write my moment equation. So it's not an up arrow, this is like a rotating counterclockwise. We have the moment of A set equal to 0. So let's go through our forces one by one. So we have our, I'm going to erase this and break it up into its components. So we have E cosine alpha and E sine alpha. All right. So first things first, we have E sine alpha, and that is 8 inches away from point A, and it's going to rotate it in the counterclockwise direction. This is for E sine of theta. It's going to rotate it like that. So that gives us positive E sine theta times 8. So 8 times E sine, sorry, not theta, alpha. And then we also have cosine, that is 5 inches away, seen right here. This distance right here, because this is 13 minus 8 is 5. And it's also going to rotate it in the counterclockwise direction. So plus 8 E cosine alpha. Then, oh, sorry, not 8, 5. Then we have minus 26 times 10 and minus 26 times 3, and we set it equal to 0. So we can see that we only have one unknown here because we know that alpha is equal to 30 degrees. Yes, 30 degrees. So we can go ahead and solve for E, plug into your calculator, and we'll get that E is equal to 40.5756 pounds. Then after that, we have solved for the E force. So now when we take our equation f of x and set it equal to 0, we'll get a of x minus p, and then plus our e force that we had before, and make sure to use sine of alpha and not cosine, and set it equal to 0. We know e and we know p, so we can plug that into our calculator and solve for a of x, and we get a of x is equal to negative 9.13, oh, sorry, equal to 5.7122 pounds. We can take the equation for our y component and do the same thing. We can see that we already know p here, and we already know e cosine alpha pointing up. So in our equation, ay will be positive, minus p, because p is pointing downwards, and plus e cosine alpha set equal to 0. And plugging into our calculator, we'll get ay is equal to negative 9.1395. Now, what this negative symbol basically tells us is that, as you can see in our free body diagram right here, I assumed ay to be upward. Because this is negative, that means that the force of ay is really pointing downward. So if we had drawn ay pointing downwards like this, then in our equation, this ay would become negative right here, and then that negative would cancel out, leaving us with the positive value, meaning that we assumed our direction correctly. So if you get a negative value, don't worry. It just means you need to flip your direction. And to find the A force, we just take its magnitude, and that will give us A equal to 10.77 pounds. And like I said before, E is equal to 40.58 pounds. All right. So this was the case where alpha is equal to 30. Now, for the case where alpha is equal to 45, you basically follow the same procedure, and you will end up with a similar answer. So that is problem number 2.